How many of you guys out there have gravity feed smokers or want a gravity feed smoker? Or if you had more information, maybe you might be interested in it. Well, I tell you what we're going to do. We're going to do just that today. We're going to clue you in on some of the principles of operation of a gravity feed smoker, some of the benefits, some of the things to keep in mind when shopping for a gravity feed smoker. You're listening to the Barbecue Culture Podcast. Thanks for tuning in. Hey, fellas, this is Frank Cox. I'm glad you're joining us. Hey, on this podcast, we're starting to get a little bit more technical. I've got this website where we put up a form, and we're inviting people to go there. And all it is you answer one simple question. It's ask.thebbqculture.net. And when you get to that website, you just it says, what's the biggest thing you struggle with when cooking on your smoker? And so that form has been up for quite a while now, and we're getting a lot of positive feedback on there. And it seems that the biggest thing, the most common thing that people are asking about is, technical issues about, how to operate a certain kind of pit, how to control airflow, how do I control temperature in my pit, how do I get rid of these terrible temp swings, how do I get more consistency and efficiency out of my smoker? That's the biggest thing people are asking. So anyway, if you want to hear something different than that, go over there and fill that out and let us know, because that's where we're sourcing our content from, the subject matter we're talking about here. But so one of the common questions, of course, it's been mostly stick burners from startup here when we started the show. But one of the main subject matters we get asked about frequently is gravity feed smoker operation or gravity feed smoker theory or anything like that. And we have to give the man credit that come up with this whole deal, Walter Stumps. He's truly one of the pioneers of barbecue, and he absolutely came up with a fantastic design for a gravity feed smoker. And it's won a ton of competitions. It's incredibly useful in catering and all different sorts of operations. And so we want to give him a shout out first of all for inventing that amazing smoker. And so over the years, there's been a lot of different people build that kind of smoker, and a lot of different concepts have been brought up. And we've got a couple of different ways we've built it over the years. Many people have bought our plans that we have a couple different sets of plans for a gravity feed smoker that you can get and build it yourself. But anyway, out of all the different designs, Rebel, Superior, there's a bunch of different ones out there. Myron Mixon even has one, Stumps, of course. And then, our design. What you wind up with essentially is an insulated cabinet. Some different brands have different wall thicknesses. We're going to speak specifically about our design in this particular episode. Our design, we call for 1.5 inches thick wall thickness on our smoker plans there, and we use a mineral wool rigid board style insulation in there. That's we recommend you use Roxul, is the brand, ROXUL, and that insulation is about a 2100 degree insulation, and it holds up really well. The biggest benefit of using that insulation is that it don't fall down inside the walls as you're bouncing that pit down the interstate and it gets rained on or whatever, and some moisture, condensation, grease, whatever from leaks, different things happen and get the insulation wet. It's not as subjected to that, so that's one reason why we recommend it. It's also easier to work with. But so essentially you're dealing with an insulated steel cabinet And ours is about 1.5 inches thick. And we're going to have a series of cooking racks that are placed vertically on top of each other. And it's going to have a large, door on the front that opens up the entire inside of the cook chamber. And when you open up that door, you're going to see below the cooking racks, about the lower foot of the cook chamber, you're going to see this weird looking tube in our design. Some other designs just have a flat plate. Some of them have a drain pan. There's all different ways of doing it. But ours has got like a transfer tube is what we call it. It's a channel that's upside down, so the bottom is open, and the products of combustion, or the warm air mass that comes from the fire, passes under that channel, and as it goes across, there's only one way for it to go, is to spill out straight down. Even though it's a warm air mass, it's going to pressurize and push down, and that's going to cause our air mass to kind of mix a bit, so that we get an even cook chamber left to right, even cook chamber temp. And then it's gonna tend, after it does that, to try to draft straight up towards the top. And when it gets up to the top, it's gonna kind of turbulate a little bit. As it's going through the meat, it's gonna hit the top, and it's gonna have to find the exit in the cook chamber out the smokestack. So that's gonna give us a little bit of natural convection inside the cook chamber. Now, you're not moving air like if you blew air out your mouth. You're not even move that much air. You're moving a very, very, very small amount of air. We're talking like 5 cubic feet per minute. So what is a cubic foot of air? So we're talking about a literal cubic foot of space. That's called a volume. And the cubic feet is how many volumes are moving in a given length, based on other design criteria like static pressure and things like that. So we're moving that volume of air so many feet per minute velocity. So that's like it's very, very, very small amount of air. It's like almost none whatsoever. So we rely on pressure in the cook chamber to help us get convection. I.e., an example, the smokestack damper is closed down, to cause restriction. So now we go backwards from the cook chamber, we go through the transfer tube we just talked about, and we go into a place that we call the burn chamber. The burn chamber on our plans is constructed out of 1/2 inch thick iron. And what we do is, because that's literally a forge, like you would see a blacksmith blowing flames, into and coals and getting it really hot. And we want that to last for a long time, so we recommend that that's built out of 1/2 inch thick iron. And then, so that's literally where the fire is. It's a very small area, typically about 10 inches square or so. On different models, it's different sizes. And so you're going to fit, not quite a pound of charcoal, maybe a pound. It's about 6 inches tall. And that's the area where we want a fire burning. That's the height of our transfer tube. Where it leaves that burn chamber, it goes directly into the cook chamber. So below that area is a place called the ash box. So the ash box, when the charcoal is on fire, it's sitting on a log rack or a charcoal grate, and that's usually constructed out of pretty heavy steel. And as that charcoal is burning, it's turning into ash as it's consumed, and it falls down into that ash box at the very bottom. That's also where our combustion air comes in from our blower or natural draft, whichever you're using. And that's where we're going to control how much air comes into that coal bed. So the air comes in through the air inlet or the ball valve or whatever you're used to seeing, the fan comes in through there, and the only place it can go is upwards through that charcoal grate. And then the design of the chute or hopper that sits on top of that burn chamber prevents air from going straight up. It can only go out through that transfer tube into the cook chamber and out the smokestack. So we're controlling the pattern of air where it goes. So let's go back into the chute again, and we're going to go directly above that burn chamber, and that's what we refer to as the chute or the hopper. And at the very top of that hopper, it's full of charcoal, at the very top is a door, and that door is sealed completely shut. No air can leak through it. And so that prevents the fire from drawing air from above, which keeps the charcoal above the burn chamber from being on fire. And on our design, we have a kit that we manufacture, and we also have a turnkey smoker that we build out of that kit. On that particular pit, you can hold your hand on that door up on the very top, and you won't feel any heat whatsoever coming up. It's just like room temperature right there, because there's no warm air mass going up. There's only one direction it can go because of how well it's sealed. So what we do, we've got 20 pounds of charcoal inside of there. And if you've ever lit 20 pounds of charcoal on fire in just open air, prepare yourself, because it is an inferno. I mean, it really lights up. And if it's in a chute or a cylinder of some kind that's vertical, that the top is open, that's why rocket stoves work the way they do. You basically got a flamethrower. So it's very, very, very important that you keep the top of that chute completely sealed and do not let the door be open. Otherwise, you'd have a flare-up of mammoth proportions. So anyway, what we do is we control our cook chamber temp with the ball valve on the opening coming into the air box or the ash box, or with a digital temperature control that's hooked up to a fan motor that is in charge of blowing the correct amount of air into the ash box to go through the coal bed. So I hope that's making a little bit of sense. I'm going to touch on one more thing here just to kind of hopefully answer another question or two. The other issue we run into is how do we light this thing? So when you're lighting the first fire in your gravity feed, it's an empty chute. My preferred way to do that is to open up the top door, open up the ash box door, and open up the cook chamber door. And we're going to take a charcoal chimney, like a Weber charcoal chimney, and one of the big ones. I prefer to use a pretty good size one on a bigger pit, like our double pan. And I'll light that charcoal chimney on fire. Usually I use a gas burner of some kind. And what I like to do is get that charcoal to where the very top of the charcoal chimney is starting to kind of turn a salt and pepper kind of a color. It's not all gray. It's not all black. And I like to take the charcoal chimney at that point and dump it down the chute from above. And all that charcoal is going to go down and sit on that burn grate. And then what we're going to do is we're going to take a bag of charcoal, and we're going to dump it down on top of the lit charcoal. And we're going to fill the chute up. You don't have to go all the way full, but you know, if you're going to cook for a long period of time, go ahead and fill it all the way up. And then we're going to let that door on top of the chute be open for a little while. What we want to do is we want to start burning charcoal and getting it lit and getting it hot. That's sitting on top of that lit charcoal. I usually do that for about 5 minutes or so. Just leave it open. Not a long time. Then we're going to shut the top door. We're going to shut the ash box door, and we're going to shut the cook chamber door. And for a little while, we're going to open our chimney on our cook chamber all the way up. Get our draft controller running, or run the ball valve, however you want to do it. And we're going to start getting that cook chamber hot. Once that cook chamber comes up to temp, we're going to crack that chimney down to about half. The chimney on the cook chamber, crack it down to about half, so we can cause some restriction in the cook chamber. That way the air has some dwell time inside the cook chamber, and we're able to even out the inside of the cook chamber temperature. Anyway, at that point, the only thing you got to pay attention to is if your cook chamber temp starts to take a dive, you want to make sure and check that the bottom of your burn grate isn't restricted with, just like any air gaps or any bridging or anything like that in the charcoal, preventing it from falling down. On some models, the chute is straight up and down vertical, and charcoal can bridge in that chute and prevent it from falling down. So you might have to take a rod from up above and hit on it a little bit. In some cases, like if for whatever reason you wind up with what I would call a clinker, which is just a ball of something that just won't fall through, like ash, take and wrap on the bottom of that burn grate a little bit with a hammer or something, keep your hand back and let some of the ash render down. And then, shut the door right away, and that'll help you with, get your cook chamber back under control, your cook chamber temps. Well, fellas, I hope that helped out. I just pulled in the house here, in the garage here, if you heard the dinger dinging, so I better get on in the house. But I wanted to thank you for listening to our podcast, and give us a review. If you're on iTunes, go to the bottom and then click on the stars, give us a rating, and write a review. We would sure like to hear your thoughts on how we're doing with our show. And if you're on one of the other platforms, they got the same thing going. I just don't know where it lives. So anyway, peace out, brothers and sisters. Light a fire, invite somebody, convert them to the barbecue culture. We'll see you on the smoky side.